Okay. Hi, everyone. This is CSM 61A, worksheet 6, question 2 on dictionaries. So let's start by reading this problem and then going over some properties of dictionaries. So first, what we're given is a digraph is any pair of immediately adjacent letters. So let's start off with an example to visualize what a digraph is. So in the word auto, we first have OT. That is our first digraph because those are the first two letters of our word. So OT will be a digraph. In addition to that, we also have TT because those are the next two letters, and TO because those are the two letters following that. Okay, so now we know that a digraph is just a pair of two letters that are next to each other in a word. So what we would like to do is we would like to write a function called count digraphs, which will take in a piece of text, so a string text that is passed in, and it will also take a list of letters that we call alphabet. And what we will do is we want to go through the string text and all the letters that are in our alphabet, if they appear in a digraph, we want to include that digraph in our final dictionary. So lastly, what is our final dictionary? What do we want to actually return? Well, we want to count the number of times that each digraph appears in this text. So for example, let's go through the doc tests to see how this works. So in our first example, again, we have auto, and the alphabet passed in is O and T. So let's go over this one by one. Our first digraph is OT right here. So because O and T are both in the alphabet that's passed in, they are a valid digraph, and we will add them to our dictionary. So as you can see, we have OT has a value of 1. Then we will go to TT. TT will have a value of 1, and then we'll go to TO, which will also have a value of 1. Okay, so let's go through the second doc test. Now, in this one, there's only one valid digraph, which is TT. And the reason for this is because T is the only letter in our alphabet. So since O is not in our alphabet, then if it's in any digraphs, it will not be valid. Because again, our definition of a valid digraph is that both of the letters must be present in the alphabet. Okay, and finally, let's go over this last doc test to get a better understanding. So our alphabet here is 6 and 1. Okay, so in our dictionary, we want to include any digraphs that are valid, and these valid digraphs can only contain the characters 6 and 1. So first off, we have 6, 1 as our first digraph. So we will add 6, 1 to our dictionary. Then we have 1, 6. So we will add 1, 6 to our dictionary. Then again, we have 6, 1. So now, because we have two 6, 1s, as you can see, the value of 6, 1 in this dictionary will be 2, because it has a frequency of 2 in this text. And 1, 6 will have a frequency of 1, because as we see, it occurred once in our string text. Okay, after that, we see there are no more valid digraphs because we have a space and then a 6. So because a space isn't in our alphabet, we can't include it in any valid digraphs. Okay, so yeah, let's start getting into the coding portion of this question. So we're given the skeleton code here, and the first thing that we notice is frequency starts off as an empty dictionary that we return at the end. So we know that as we write our function, we want to continue to write to this frequency dictionary, which will be our final return value. So therefore, we know that frequency will store the keys and the values, where the keys are the digraph and the values are the frequency with which that digraph appears in the text. Okay, so to start this problem, let's think about what strategies we can use to loop through text. So we know that we can use a for loop to loop through every character in a string, because a string is a sequence that can be looped through. Now, since we're working with digraphs, we essentially want to work with our characters as groups of two. So that means that when we loop through the string, we want to loop until the second to last element, because our loop will first evaluate the first and second elements, then the second and third elements, and so on. So if we loop until the second to last element, that means that we will end our loop looking at both the second to last element and the last element. So that means we can write our for loop now. So for I in range, and then we want to have it loop up until the length of text. And since that will loop all the way to the very end, we can subtract 1. Okay. So now we know to loop up until the second to last element of text. And this is what for I in range length of text minus 1 will do. Okay. So now we see that we have an if condition here. So let's look back at our problem description and try to learn more about what we could do with this if condition. So we see that count digraphs takes in a list of letters alphabet, and it will only count digraphs as valid if both of the letters in the digraph are in the alphabet. So, okay, that makes me think that in this if statement here, which the rest of the code then follows, we should check to see if our digraph is valid. So that way, in the rest of the body of this function, if it is valid, we can add it to our frequency dictionary. So now the question is, how do we actually access this digraph? Well, again, we're looping through every index of text. So what we can do to create the digraph is we can check if text I, since that would be the first portion of the digraph, if text I is in alphabet, and text I plus 1, because that would be the next letter, is in the alphabet. Okay, so let's think about what we've done here. So in order to check whether or not our digraph is valid, we're checking text I and text I plus 1, because these are both the two characters of our digraph. And then we're checking if they are in alphabet, so they can both, if they are both in the alphabet, they can be counted as a valid digraph. Okay, so since we know text I and text I plus 1 are the two elements of our digraph, all we have to do is add those together and assign it to our digraph variable. So now, as we continue to loop through text, we will keep setting digraph to the two nearest characters. Okay, so lastly, what we want to do is we want to actually add the frequency of this digraph to our dictionary. So we have two cases in general when implementing dictionaries. So the first case is that for the digraph we come across at this part of the loop, it already exists in our dictionary. And in this case, we can take whatever value exists in this dictionary and just increment it by 1. But there's also a chance that this digraph does not exist in our dictionary. And so in this case, we would actually have to manually put it in the dictionary. We can't increment it by 1 because it doesn't exist. So to check for this, we can say if digraph is in frequency dot keys, because what this will do is it will check the keys of frequency, and it will see if digraph is in this keys list, meaning that it's already in the dictionary. So if digraph is in the dictionary, then we can just increment its value by 1. So to get the value in this dictionary of digraph, we can just index as such. Frequency at digraph is going to be incremented by 1. Because again, in dictionaries, the keys that we use to index can be anything. And in this case, they are strings that we call digraph. Okay, else. So this means that the digraph is not in the frequency dictionary. So we have to create it ourselves. So we can write frequency at digraph is equal to 1. Because in this case, we are initializing this key in our dictionary, and we know that its frequency will be 1 because this is the first time that we've come across this key, since it doesn't already exist in our dictionary. So we have a frequency of 1 because this is the first time we have accessed this digraph in our text. So again, we can think about this function as a whole now. We start by setting an empty dictionary, then we loop through text, and remember to subtract 1 in our range because we're looping 2 at a time. So once we've gotten to the second to last element, we know we can stop because at the second to last element, we will check both that and the one ahead of it, which is our final element. Next, we check if our current digraph is valid by checking if text I and text I plus 1 are both in the alphabet. And if they are, then we say, okay, we can set our digraph variable to be equal to text I plus text I plus 1, since these are the two nearest letters that are adjacent to each other. And then finally, we check if the digraph is already in our dictionary, in which case we will add 1 to its value because we've come across another instance of this digraph. Otherwise, if it's not in our dictionary, this is our first time seeing this digraph, so we will just add it to our dictionary by setting it equal to 1.